6.4 is on completing the square. So the first few are just kind of introduction problems. It's going to kind of show you this process that we're going to do. So it says some equations can be solved without factoring. So if you can get it into the form like x squared equals a number, or x minus a number squared equals another number, then you can just take the square root of both sides and solve. Okay, so that's what I sometimes call the square roots method. So if you want to write that down, square roots method. So for number 1, I'm going to add the 5 over. So I get 3x squared equals 72. And I divide by 3. So I get x squared equals 24. And I solve. So I don't find a decimal answer or anything. I just simplify a square root. So if I have the square root of 24, so I'm going to do square root of both sides. Remember, when I take a square root, I write plus or minus. So I get x equals plus or minus the square root of 24, which is really like square root of 4 times square root of 6. Do you guys remember simplifying our square roots? So how would we write this? Yeah, plus or minus 2 root 6. And that would be our answer. Okay, so that's the first one. So if we just had x squared in the end, x squared equals a number, we can take the square root of both sides. So for number 2, it's the same idea, so go ahead and try it along with me. So try to subtract 11, subtract 11. So I get 4z squared equals 48. I divide by 4. So I get z squared equals, started to write 24, I don't know why. And so when I take the square root of both sides, I don't forget to write a plus or minus. So plus or minus the square root of 12 is going to break into plus or minus, exactly, 2 root 3. Do you guys remember doing like the little factor tree? You can always do that if you get stuck, and you can say, oh, I have a pair of 2's and I have a 3 by itself. So the square root of 4 gives me the 2, and then square root of 3 stays how it is. All right, so that's the first kind. So the next two are what involve perfect square trinomials. So I know that you guys probably don't understand all of the math words, so I'm going to explain that to you. So this is what we would call a perfect square trinomial. So basically, if I have c squared minus 6c plus 9 and I try to factor it, it factors into the same thing in parentheses times itself. So let's try to factor it. So if I have c squared minus 6c plus 9, I would need c and c at the beginning. And I need 3 and 3 at the end. Yep, and I need my outer and inner to combine to be negative 6, so I need a negative and a negative. So it factors into c minus 3 squared. That's what we call a perfect square trinomial. Perfect square meaning it's something squared in the end. All right, and that's all going to equal, on the other side of the equation was 10. Please put your phone away. Do I need to take it? All right, so I'm going to take the square root of both sides. Plus or minus. So I get c minus 3 equals plus or minus the square root of 10. All right, so if I'm solving for c, I want to get the c by itself, so all I need to do is just add the 3 over, right? So just add it over. And typically when I add it over, I just kind of sneak it in the front of that plus or minus. So I write my answer as c equals 3 plus or minus the square root of 10. And I do that really because sometimes the 3 gets kind of underneath that square root, and people are like, oh, square root of 13, but it's not square root of 13, right? So 3 plus root 10, you can't go any further. We leave it like that. So do you guys see that that's actually 2 different answers? So all of these so far have had 2 answers. So the first one was 2 root 6, and then negative 2 root 6, positive 2 root 3, and negative 2 root 3. This one has 2 answers as well, 3 plus the square root of 10 and 3 minus the square root of 10. So you could find decimal approximations if you want to, but that's not the point of this. We're writing the exact answer. Okay, so let's try the same thing on the next one. So this is a perfect square trinomial again. So when we factor it, we do our 2 sets of parentheses. So I'm going to get y and y. And I need numbers here, 6 and 6, so that when I combine my outer and inner terms, I do get my 12. and my last term's combined to be that 36. So it's going to be y plus 6 times y plus 6. Okay, and you'll start to notice that there's a pattern to this section. Okay, so tell me about this number 6 that I have right here. Number 6. How is that related to 36? It's the square root of 36. How is it related to 12? It's half of it, right? Does that make sense? So 6 plus 6 makes 12. So if I had both of them, right, that's how I'm getting 12. So that 6 is kind of a magical number there. So it's the square root of this, right? And it's half of this. So both of those are going to be equal to 6. So we have to have it in a special form. So even if I gave you like x squared minus, I don't know, like 14x plus something, what would the magical number for that one be? 49. Does that make sense? Do you guys see it? All right, so we're going to be doing this a lot. We're going to be finding that number. Okay, there's a way to find it, but we're kind of previewing where we're going. All right, so I have x plus 6 quantity squared. So I'm going to now take the square root of both sides and write a plus or minus. So I have y plus 6 equals plus or minus 7. And I subtract the 6 over. So I get y equals negative 6 plus or minus 7. Okay, I do not leave my answer like this. I'm not going to box it in at this point. How is this different than the last one? The last one I left is 3 plus or minus the square root of 10. Yeah, Caleb, what do you think? Yeah, they weren't like terms, right? We couldn't combine them. But this time we can. So we can say, oh, this is going to be y equals negative 6 plus 7, which is 1. Is the other one negative 1 then? No, be careful. It's going to be negative 6 minus 7, which is negative 13, exactly. It's not like plus or minus. A lot of people think, oh, if I got 5, then negative 5 is my other answer. Not always. Okay, when you get nice integers like that, like see how these worked out to be really nice answers? Really, if I had a rational number, like a fraction answer even. So if I ever have anything that doesn't have a square root and doesn't have an I, then really at the original, I could have actually factored that, which is much, much easier than doing what we did here. So another method for this one would be to say, oh, I have y squared plus 12y plus 36 equals 49. I'm going to subtract the 49 over. So I get y squared plus 12y minus 13, and then we factor. Isn't this what we did in the last section? Do you guys remember doing this? So we set everything equal to 0 and we factor. It's hard once I get over here on the edge. It doesn't want to write once I'm over there. Let's just say equals 0 over here. So I get y equals 1 and y equals negative 13. A lot of times factoring is much, much faster. Okay, especially when we have all of these like fraction answers and so on. Completing the square with fractions is not so fun. Right, so this is why we learn all these different methods. Okay, so we're going to learn 3 different methods in this class. We're going to learn factoring, which sometimes works but doesn't work when we have square roots or i's. Completing the square works for everything. And the last method that we're going to learn, do you guys remember it from Algebra 1? Section 6.5, quadratic formula. So we're going to be learning all these methods. We'll be talking about it next section. I know you're so excited. Okay. So we can use the above methods if we get our equation to one of those special forms. So this process, so if we get it into the place where, remember how I said there was that like magic number that made it perfect, like made it a perfect square? If we can do that, then we can complete the square. Then we've completed the square, okay? So steps to completing the square. So get your equation in the form x squared plus bx equals c. So in order to do this, you might have to divide by the number in front of x squared. So basically this is a 1x squared. We need a 1 in the front. So that's where we might have fractions, a 1x squared. So divide by the number in front of x squared. All right, then we're going to do what we call have it and square it. So in other words, we look at the coefficient on the x term, we divide it by 2, and we square it. So add this result, which is b divided by 2 squared, to both sides of the equation. We then write the left side of the equation as a perfect square, and then we solve by taking the square root of both sides of the equation. Don't forget your plus and your minus. So we're always going to have 2 answers because of the plus or minus. All right, so number 1, so it says solve each equation by completing the square. So the first thing we need is we need it in the form, so need x squared plus bx equals c. We need it in that form. So what do I have to do first? Yeah, subtract that x over. So get all your x's on one side basically. Okay. So now we take that number that's in front of our x and we have it and square it. Okay, we find basically what's making it a perfect square trinomial. So if I take that negative 12 and I do my b divided by 2 squared, don't get it confused with the negative b over 2a, right? New formula. So b divided by 2 squared. I take my negative 12 divided by 2 and I square it. So negative 6 squared is 36. Okay, I just wrote out a bunch of steps that most of you guys are going to be able to do in your head. So I just take that number, I divide it by 2, and I square it. When I do that, it does what we call completes the square. It makes it a perfect square trinomial. So I have x squared minus 12x plus 36. We put that in like a little box so you can see I added up that. And whenever I add something to one side of the equation, I have to add it to both sides of the equation, right?
Wait, but how did you get the 36 and still keep the 12x in the first place?
The 12x doesn't change. I'm just adding 36 to both sides of the equation. So the whole equation is the same. It's just we're keeping it balanced by adding the same thing to both sides.
It would be 56 though?
It's 36. So we're keeping that negative 20 over on the right-hand side. All right, so when you do this, we did it for a reason, right? I realize that there's a negative 20 over there. We're not combining it. We did this for a reason. So this now becomes what we call a perfect square. So it factors perfectly. So if I factor it, what does it factor into? Yeah, it's x minus 6 times x minus 6, right? And then the right-hand side, negative 20 plus 36 is 16. So we write it as x minus 6 squared equals 16. This is the form that I wanted in, because now in order to solve it, I can do that square roots method that I was talking about. I can take the square root of both sides, and then I can add that 6 over. Do you see it? All right, so we take the square root, write plus or minus. So I get x minus 6 equals plus or minus, the square root of 16 is 4. We add the 6 over, so we get 6 plus or minus 4. So what are our two answers? X equals 10 and x equals 2. Perfect. Good. I don't know why I circled it like that, but I'll circle each one. All right, does that make sense, Greta?
So is x equal 10 and x equals 2, are those the zeros?
Those are the zeros, exactly. It relates back to that. So could I have found that in another way? Yeah, in that case I could have factored. Did you guys see if I had x squared equals 12x minus 20, I could get them all onto one side, and I can factor. So I can do x minus 10 and x minus 2, and I get answers of 10 and 2. Exactly the same thing. Was factoring a lot faster? Yeah, it was a lot faster. So if we can factor, we usually do, right? But if you see that you can't factor, then you can do completing the square. And that's when you're going to have a square root answer or an I answer. Clay, are you with me? All right, so let's do the next one. So I have 3x squared minus 24x equals 27. So I need x squared plus bx equals c. So the important part about that is it's 1x squared. Okay, yeah, so we're going to divide everything through by 3. And in this case, it's okay, we don't get fractions, but sometimes we're going to have fractions, and we're going to go with it. So we're going to have x squared minus 8x equals 9. I believe this is another one that would actually work with factoring. But. All right, so let's do our completing the square method. So we're going to do our b divided by 2 squared. So we're going to take that negative 8, I'm going to divide it by 2, and I'm going to square it. So what do I get when I do that? 16. Do you guys see it? So it was negative 4 squared is 16. Most of you guys, like I said, are going to be able to do this without even writing anything down. You're like, oh, I'm going to add 16 to both sides of the equation. Because you're going to know, have it and square it. So when I do x squared minus 8x, I'm going to add 16 to both sides. You don't have to do the little box around it. I find it just helps when you guys are taking notes to see it. So that makes that left-hand side of the equation a perfect square trinomial. It makes it so we can factor it into something squared. So if we were factoring this, we would need x minus 4 times x minus 4. That negative 4 comes from here. It's what you had before you squared. Do you see it? It's the number you had when you divided by 2. It's always that number. Because that's the number that's going to be the square root of 16, but then also if I have both of them, they're going to add to be that negative 8. Right? Negative 4 make negative 8. It's half of negative 8. All right, equals 25. So I'm going to have x minus 4 squared equals 25. Now that's in the form that I like. So when I'm finishing this out, I'm going to take the square root of both sides. You with me, Manish? Square root of both sides, plus or minus. So I get x minus 4 equals plus or minus 5. I'm going to add that 4 over, so I get x equals 4 plus or minus 5. So I get 2 answers. 4 plus 5 is 9. 4 minus 5 is negative 1. Yeah, Christian?
Couldn't it also be negative 9?
Nope.
Positive 1?
Nope. Because you would do 4 plus 5 is the first answer, and 4 minus 5 is the second answer. So you use the plus for the first one, and you use the minus. Nope. Nope, because you're adding that 4 over. So you could do plus or minus 5 plus 4, but it's still the same thing. Positive 5 plus 4 is 9. Negative 5 plus 4 is negative 1. All right, so let's try some harder ones. You ready? All right, same thing. We want in that form x squared plus bx equals c. So I'm going to first write my 3x squared first. And then what am I going to divide by?
3.
Yeah, divide by that 3. So we're going to get x squared plus 6x equals 15. All right, can you guys do it in your head? What number do you need to add to both sides to make that left side a perfect square? 9. Do you guys see it? Okay, we're doing the b divided by 2 squared. So we're taking this number, we're dividing it by 2 and squaring it. As I was saying, have it and square it. So 3 squared is 9. That's what we're adding to both sides. So I'm going to have x squared plus 6x plus 9 equals 15 plus 9. So I added that on both sides. It now makes it something that I can factor. It's going to be something squared, right? Something times itself. X plus 3. Greta's got it. The rest of you guys got it? All right, 15 plus 9. 24. So I have something squared equals a number, so I can take the square root of both sides. Square root, plus or minus. So I get x plus 3 equals plus or minus the square root of 24. So how do I simplify square root of 24? 2 root 6. You guys are on it today. Look at you guys. All right, so 2 root 6. Subtract it over. So subtract that 3 over. So negative 3 plus or minus 2 root 6. And that's your answer. That's representing 2 different answers. So I think on your homework I have like answer blanks and it's like x equals blank, x equals blank. So you would put negative 3 plus 2 root 6 and you put negative 3 minus 2 root 6 as your answers. All right. So we have square root answers. Could we have I answers? Yeah. You guys thought I's were going to go away, didn't you? They don't ever go away once you learn them. They're always around. All right, so we're going to have x squared plus 8x equals 4. I think this one's not an I answer, though. Maybe the next one. All right, so what do I need to add to both sides? Are you guys all at the point where you can see what you're adding to both sides? So Evan, do you see what you're adding to both sides? Manish, do you get it? Yeah. So you're doing b divided by 2 squared. So 8 over 2 squared is 4 squared,
But how do you know
which
that
is
it's
16.
that specific number?
What do you mean, how do I know?
I mean, how do you know that you're specifically supposed to divide by 8? How do you know that b is 8 in this case?
Because it's a, b, and c that we talked about before. They're always a, b, and c. It's always in the form ax squared plus bx plus c equals 0. 6.1, 6.2. It's every time we write a quadratic formula, it's like using a, b, and c. A quadratic equation. We'll use it in the quadratic formula as well. A, b, and c. How have you not seen the quadratic formula?
Well, I mean, I know I've seen it. It's just no one's ever bothered to explain what it means.
Well, that's the joy of next class. You get to learn about the quadratic formula. I'm even going to have songs about it. You excited about songs? Yes, one is to get low. I know. Really? Get low, right? But it's catchy. I like it. All right, so here we go. So we're going to factor. So if I factor x squared plus 8x plus 16, it factors into x plus 4 times x plus 4. So it's going to be x plus 4 squared equals 20. All right, square root of both sides. So I get x plus 4 equals plus or minus the square root of 20. How do I simplify the square root of 20? 2 square root of 5. Perfect. So when I subtract that 4 over, I get x equals negative 4 plus or minus 2 square root of 5. Thumbs up? Still feeling good? Scale of 1 to 10, 10 being easy. Are we at like a 9 at least? 8. 8 is respectable. I'll take an 8. Really, practice makes perfect. When you guys do your homework, you'll be like, oh, I got this. All right, so here we go. So x squared minus 4x plus 6 equals 0. So let's do a couple more. Maybe we'll go through 7, and then I'll give you your homework. All right, so let's subtract the 6 over. So I'm going to have x squared minus 4x equals negative 6. I'm going to do my b divided by 2. So I'm going to take that negative 4. I'm going to divide it by 2. I'm going to square it. So negative 2 squared is 4. I'm going to take that 4 and I'm going to add it to both sides, keep my equation balanced.
Why exactly are we dividing it by 2 every single time?
It's the formula. There's calculus involved. I can show you the calculus if you really want. It's fascinating. My calc students always like it. They're like, oh my gosh, that's where that formula came from. I'm not going to show you. I can, but that's a tangent. I think you'd rather have your homework soon, right? All right, so I'm going to factor. So it factors into x minus 2 times x minus 2. And this time it's equal to a negative number. What do you think? Yeah, it's going to be an imaginary answer, right? So square root, plus or minus. So I'm going to get that x minus 2, and it equals plus or minus the square root of negative 2. How do we write that? Remember, it's the square root of negative 1 times square root of 2. So I root 2, right? So it's going to be I root 2. So basically, I always say, like, you'll hear me say this a lot, pull the negative out and write it as an I, right? It's like square root of negative 1 is I, and then square root of 2 is left how it is. All right. So we just add the 2 over, that's it. So you guys were all scared that the I's were going to be hard. Easy, right? You got this. All right, the hard part is fractions. We love fractions, though, don't we? Now that you're in Algebra 2, aren't fractions your friend?
No.
Oh, not so much. All right, so remember, we always want a 1x squared. So we're dividing everything through by 3. So first add the 10 over, I guess. So we're going to divide by 3, divide by 3. So it starts out and it's like, oh, I got this left-hand side. The left-hand side is x squared minus 2x. That's great. But what's the right-hand side? 10 over 3. So we're going with it. 10 over 3. Violet. All right, so I'm going to add a number to both sides of the equation. What number do I need to add? Right, I take that number, negative 2. I divide by 2. I square it. Yeah, so I'm adding 1 to both sides. So those of you that are not frightened of fractions know this immediately. You're like, oh, 10 thirds plus 1, that's going to be 13 thirds. Those of you that are scared of fractions are just like, oh my god, why are there fractions? 10 thirds plus 1. All right, can we do it? Right, so common denominators. So we're going to do 1 is 3 over 3, and we're going to add them together. That's all we're doing, 13 thirds. Now the left-hand side is x minus 1 squared. Take the square root. Even Abby's getting uncomfortable over there. Abby's a math superstar back there. She's like, I don't know about the square root of 10 thirds.
13 thirds.
Or 13 thirds. No, I just always say the wrong thing. Sorry. Square root of 13 thirds. So square root of 13 over the square root of 3, right? That's what square root of 13 thirds is. It's like a square root on both of them. So Rodrigo's like, square root on the denominator. It just bothers you so much, doesn't it? Multiply by square root of 3 over square root of 3. So I'm going to get x minus 1 equals plus or minus the square root of 39 over 3. And I'm going to add that 1 over, so my answer is x equals 1 plus or minus the square root of 39 over 3. That is your answer. All right, so they do get a little bit nasty. I don't think I have one that's that bad on your homework. But.
Why wouldn't you simplify
The 39 over 3? Because one's under a root and one's not, so you can't combine them. You see it? All right, let's do one more fraction, then I'll give you your homework. Ready? You can handle this. Yeah? Oh, do I need to go back? All right, so try the next one. So you have 8x squared plus 4x. All right, divide everything by 8. See what you get. You should have a 1/2. We have to take 1/2 and divide it by 2, and then square it. 1/2 divided by 2. If I have half a pizza and I divide it into 2 pieces, then I have a fourth of the pizza, right? It's not 1. Some people were saying 1 in the last class. Right. Oh, fractions. Someday, all my students will be like, oh, I got this. Not so much. Divide by 8, divide by 8. So I have x squared plus 1/2 x equals 12 over 8 was 3 over 2, right? Divide by 4 on the top and bottom. So when we're saying 1/2 divided by 2 squared, that's kind of complicated writing that, right? That's what we call a complex fraction, a fraction within a fraction. So you can write it like with the old school division sign, like divide by 2, like that. And you guys remember how that's 1/2 times 1/2, right? Take the reciprocal, which is 1/4. So 1/4 squared, what do we get? 1 over 16, that's what we're adding to both sides. So x squared plus 1/2 x plus 1 over 16 equals 3 over 2 plus 1 over 16. This is what fractions do to you. You can handle this, I promise. Even on a U day, when you go till 3:15, man. All right, 3 over 2 plus 1 over 16. Get common denominators. Yeah, they're both 16, right? So it's going to be 24 over 16 plus 1 over 16. So we get 25 over 16. And when we factor, the magical number that we need is always what we had when we divided by 2. It's right there. So that goes right there. Because 1/4 times 1/4 gives 1 over 16. But 1/4 plus 1/4 gives you 1/2, right? So we have x plus 1/4, quantity squared, equals 25 over 16. Okay, we're going to need some teamwork. Are you guys ready for the challenge?
Could I ask, why did you want to get 1/2 exactly?
Because you want the outer and inner to combine to be x times 1/2, 1/2 x.
Well, why did you want 1/2 in the first place?
Because I'm trying to factor that. So I want my outer and inner to combine to be that 1/2.
What
Remember
does that
factor?
have to do with the factor?
I don't know how to answer that question.
You know if there would be some place where I'd ask more questions?
Yeah. All right, plus or minus. All right, Claire. Square root of 25 over 16. Take the square root of the top and the bottom. What do we get? 5/4. Okay, so I'm going to have x plus 1/4 equals plus or minus 5/4. All right, I'm going to subtract that 1/4 over. So I have negative 1/4 plus or minus 5/4. All right, here we go.
Isn't 25/16 not 5/4?
The square root of 25 over 16 is the square root of 25 over the square root of 16, which is 5 over 4. So square root of 25 is 5, square root of 16 is 4. All right, Maya, negative 1/4 plus 5/4. Negative 1/4 plus 5/4. What do we get? You guys, I was asking Maya. Negative 1/4 plus 5/4. What do we get? 4/4, which is 1. Right? And then how about the next one? Negative 1/4 minus 5/4. Sam, how about you?
I got 3 over 2.
Oh, she even simplified it. Negative 3 over 2 is correct. Those are the answers. Now, since I got nice numbers like that, well, these are really nice, super nice, but since I got rational numbers, no square roots or i's, really what could I have done at the beginning? Factoring. Do you think factoring would be easier than completing the square?
Yes.
Yeah, that's why we learn how to factor. Right, it's amazing. It's much faster. All right, let me give you your homework.